Start with. And summation of primes. This question asks us to find the prime numbers which, for example, the prime numbers which are less than 10 are 2, 3, 5, and 7. Their sum is 17. It asks us to find some of the prime numbers below 2 million. So I use the method named sieve of Eratosthenes. So in this method, we start writing all the numbers between 1 and that maximum number. For example, here I write them from 1 to 10 for an example. 1, 2, 3, 4, 5, and then 6, 7, 8, 9, and 10. And to find out if a number is prime or not. So if a number is prime, I will put them instead as 0 or a negative number of your number of your choice. Or you even can use a Boolean and then write it as true or false. So I go for it. First, we know that the 1 is not a prime number, so we choose false or F. And then 2, and the next number that we find is surely if it's not false, the first true number that we find is an prime number. So I said that's true. And then 3. So we figure out the 2, and all numbers that are divisible by 2, I set them as false. Like 3 is not, but 4 it is. 5 is not, but 6 is. 8 is also a prime number. And change them to false. This one is true. This one is false. This one is false because it's divisible by 2. This one is false, and this one is also false. Now I go for the next number, 3. 3 is true because it's not false and it has not yet been checked. So all numbers divisible by 3 are false because they are divisible by 3 themselves. And 5. 5, the next one is 10. So here we actually can even figure out when should we stop the checking, because we already if you have watched the question 7, I guess, I talked about the prime numbers and why we don't need to check them more than their square root. So we check for numbers until a square root of that number plus 1. Okay, so and that's a range of numbers that we are checking. And those numbers that are not checked or are not false are true. So first, I use an array and I set all the values initially as true. And so a value is false if it's not prime, and a value is true if it is prime. Here I have and this method is named sieve of Eratosthenes. Eratosthenes. And yeah. I can use big integers. I previously told you how to use big integers. Here I use another method of big integer for adding addition. So imagine m and n are 2 big integers. So if I want to say m plus n, m is equal to m plus n, I just simply write as m is equal to m that's add n. So we cannot use this, so we use this. I choose a maximum number as 2 million. Is that 2? Yeah, I guess it's 2 million. And then there is a Boolean array named not primes, as there are only Booleans inside, and the size is 2 million. And here is my method of sieve of Earthson. And this is a void method. It means that it does not return anything. It just do the calculations, put the values inside the not primes array. So later I will just need to check that array to find if a number is prime or not. This way of finding the prime numbers is much faster than the previous one that we check all the numbers that if they are prime or not. But this one has a limitation, which is you should know until which number you are looking for. So if you have the greatest number that we want to know if they are prime or not, this is the best way to find all the prime numbers between inside that range. So what I do is there's a for loop which starts from 2 until the maximum number. So if a number is not prime, so because I named this array as not primes, so if a number is not prime, then it's true, and if a number is prime, it's false. So 1 is true because 1 is not a prime number. And so 2 should be false because 2 is prime. And here the false and true is it doesn't have any meaning until you define them. Like, because I define them in this way, so true means is not prime, false means is prime. So that depends on your way. You can change them in another way. That's your choice. So I start from 2 until the square root of that number, and to make sure that that I will also check the square root for the perfect square number. I put equals here. So I will first check if the not prime is not false, then I will go for the numbers and turn them as true. So which is just the same thing as I did here. I will check if the number is not yet assigned. So I will find all the numbers that are divisible by that number, and I change them to true because they are not prime numbers. And it just have 2 for loops inside each other, and at the worst condition, this method has n times n over 2 steps. So for huge numbers, and this is much better than the previous methods. Like here we have 2 million, so this would be 2 times 10 to the power of 6 to the power of 2 over 2, which is just the same as this. This is a huge number, which is equal to 2 times 10 to the power of 12, but it is much better than the previous method to find the prime numbers. This is much faster. So what I first do is I let the sieve of Earthson function to find all the prime numbers and those that are not prime with this method, and later I will try to find the sum of those numbers. I create a big integer number named sum with the initial value of 0. And I have a for loop over that and prime not primary, and I will check if a number is not if a number is prime. So which means that by this function, by the way I define the prime numbers, the value should be false. So if the not of that value is true, so that's a prime number, and I will add the value into my function. And at the end, I will print out the results. So the result would be this. Yeah, this. And if we check it with the correct results, they are the same.